Grace and peace be multiplied unto you. I welcome you to today's lesson on the topic energy. Energy, in simple terms, is the ability to do work. Now, energy is defined as a measurable property that must be transferred to an object in order to perform work. So, there are forms of energy, about 9 or even more forms of energy. But for the sake of today, we'll be looking at, for the sake of time, we'll see whether we can finish all or not. Okay, so we have potential energy, kinetic energy, mechanical energy, solar energy, light energy, heat energy, electrical energy, electromagnetic energy. I'm sure we are all familiar with, I think, electromagnetic, electrical, heat, light, solar, probably maybe potential, kinetic, and mechanical is what we know, but we are not familiar with them. We look at their definition, and there's also a type of or a form of energy known as chemical energy. So, like I said, energy, what is energy? Energy is the ability to cause a change in matter or the ability to do work. So, energy involves movement or change in position. And there are certain laws in science. Science has to do with laws, and there's a law called the law of conservation of energy, which states that energy can never be made or destroyed. So if there's one thing I want you to know, is that energy can never be made or destroyed, but the only thing energy does is it changes from one form to another. So it can change from one form to another. Example: the car is moving, so it has energy. Where does it get its energy? It can't just make the energy it needs. So this is part of the law of conservation of energy, where energy cannot be made. So the race car's and engine changes energy stored in the gasoline or in the fuel into movement, and the car moves, and the car moves and changes position because the energy from the fuel cause the machines in the car to move the car. So the car on its own cannot move, but then it has to move by virtue or because of the energy of the fuel moving the body parts, and the body parts also moving the whole car. So energy can never be made or destroyed, but it can be transformed from one form to the other. So let's look at the first form of energy, kinetic energy. So what is kinetic energy? So when we talk about kinetic energy, we are talking about the energy of motion, the ability of something, the ability or the power that causes another thing to move. So if something is moving, it has kinetic energy. If something is moving, it has what we call kinetic energy. It has the energy of motion. The faster an object is moving, the more the kinetic energy it has. The faster an object is moving, the more the kinetic energy it has. So an airplane flying through the air has more kinetic energy than a person riding a bicycle. An airplane flying through the air has more kinetic energy than a person riding a bicycle, because it takes a lot of energy for an airplane, consider its weight, to move in the air than a bicycle to move on land. So let's look at potential energy. What is potential energy? So potential energy is the energy an object has because of its condition or position. For example, the higher an object is, the more potential energy it has. So a ball on the roof of a building has more potential energy than a ball on your desk because it can fall farther. An object can have potential and kinetic energy at the same time. So potential energy simply is the energy an object has by virtue of its position, where it is. So, for example, if like the example made, when the ball is on top of the roof, it has more potential energy. Potential energy is it has the ability to do more because it's on top of the roof. So let's take it for example, a ball on your decks or a stone on your deck falling to hit your leg compared to a stone on top of the roof falling to hit your leg. Which one has more potential energy? It's definitely the one on top of the roof because it's going to come with force and speed. So let's look at another example. The example here. As this roller coaster car moves to the top of the hill, it gains potential energy. The higher the car rises, the more potential energy it has. When the car moves down, it has kinetic energy. As it falls, its kinetic energy increases and its potential energy decreases. So what it means is that kinetic and potential energy are related. So when a car, the roller coaster here, when it's at on top, what happens is that it has more potential energy because it is then about to come down. So on top it has a lot of energy, potential energy, but on top it will be stagnant for a while, and so the kinetic energy, the ability for this thing to move, is low. But when it's going down, the potential energy drops. So the potential energy goes down, and then it goes down with speed, and kinetic energy goes up. So potential energy goes down, kinetic energy goes up because the speed will increase. Imagine something falling from top to down. It's going to increase in speed, so the kinetic energy is going to move, is going to go up. So that's how potential energy and kinetic energy are related. So a car is rolling down a hill. Describe the car's potential and kinetic energy. So when the car is here, when the car is at this point, what's going to happen is that the potential energy is going to be high. The potential energy is going to be high, and at this point it may not move, so the kinetic energy will be at its lowest. But when the car is moving this way, the potential energy will reduce. When the car is going this way too, the potential energy will reduce. But because at this stage the car will be moving, the kinetic energy will increase. And if it's moving this way, the kinetic energy will increase. Let's look at what mechanical energy is. Mechanical energy is a combination of all the potential and kinetic energy that something has. This is the energy we use every day to physically move things. When you move your chair from one place to another, you are using mechanical energy. Example, this wind-up toy has a key attached to a spring. When you turn the key, when you turn the key, when you turn the key, you wind up or tighten the spring, giving the toy potential energy. The tighter it's wound up, the more potential energy it has stored. When the toy is moving, it has kinetic energy. Since the spring is still partly wound up, the toy has some potential energy left. The toy's mechanical energy is a combination of its potential and kinetic energy. So mechanical energy is how kinetic and potential energy work together. A typical example is the toy here. So when you turn the key and you twist it, it's like a car toy. When you twist the key and then you leave it, you realize that it moves on its own. So when you turn it, it gathers a lot of potential energy, but when it starts moving, it moves with kinetic energy. Let's look at the meaning of energy transfer. So, like the law of conservation of energy said, energy cannot be destroyed, it cannot be made, but then it can be transformed. So it means that energy can be transferred from one body to another. Example, when someone is standing and then you push the person, have you wondered why the person moves? The reason is that the force coming out from your hand moves into the person and then the person moves. So the movement of energy from one place or object to another. A baseball player hits a ball, kinetic energy is transformed from the bat to the ball. A hammer strikes a nail, kinetic energy is transformed from the hammer to the nail. Can you think of other examples? So the boy in the picture here, the kinetic energy is transferred to the spring where it changes into potential energy, and as the spring expands, the potential energy is transferred to the boy as kinetic energy, bouncing him into the air. So it's standing on a spring-like structure. What are some other forms of energy? So solar, we have solar, light, heat, ultraviolet, chemical, and mechanical energy. Let's take chemical energy. So chemical energy is energy stored in fuel. It is the energy that can be released by a chemical reaction, such as burning, digestion, when it is not being used. It is potential energy. A chemical reaction is needed to change this potential energy into kinetic energy. Example, our muscles get energy from food we eat. The potential energy stored in food is chemical energy. When it is released, it gives us kinetic energy to move. Chemical energy in fuel is used to keep the remote control helicopter flying in the air. So, have you wondered why a car moves or why people buy petrol into car? This is because the petrol is burnt. So the petrol is a chemical, and then it is burnt to produce energy for the car to move. So that is a chemical energy. Let's look at solar energy. Solar energy is energy that comes from the sun. The word solar means the sun. So people use solar energy to change light energy. People use solar cells that change light energy from the sun into electricity. So we have solar calculators, solar panels that provide light and power, and solar panels to heat swimming pools. So without solar energy, the earth would just be a ball of frozen rock with no life. So solar energy is very important. Let's look at other forms of energy that comes from the sun directly. Energy from the sun travels as radiation. The sun provides different types of radiation. It provides light, the radiation we see. It provides heat, provides X-rays, it provides ultraviolet rays, radio waves, which we hear as static on radios. And some of these rays can be dangerous. Essential. So, what is light energy? Light energy is basically the energy you can see. It moves in waves. So light energy is the energy that enables us to see. Without light energy, we would all be in darkness and we can't see. So light energy basically is in the form of waves, and this is how waves look like. But we can't see them this way. We see them as linear structures. Um, that is why light moves in a straight form. So, like I saying, those waves are, however, so small and they appear to be straight lines. and then light moves through air, water, or anything. So with wave or light energy, we have something we call reflection, and reflection is what happens when light bounces off something. And also we have another word we call refraction, and refraction is what happens when light passes from one medium into another. Example, when light passes from the air into water, it bends. It no longer moves in a straight line, but then it bends as if it's broken. So you can realize that when light comes, it bends a little. So that is what we call refraction. Let's look at sound energy. Sound energy is in the form of vibrations that travel through matter. So sound energy can travel through air or space. Sound vibration pass through particles of matter in a kind of domino effect. So that's the sound energy. It's produced for the ears to hear, and the energy is recognized by the ear. Electrical energy. This is energy that comes from an electric current. It results from the movement of electrons. Electrons are particles found in atoms, and this is how an atom looks like. So the electrons are the ones here, and electricity comes about because of the movement of these electrons. It's so electricity basically is the flow of electrons. So have you wondered how a shock occurs? It occurs because electrons flowed from its source into your body, and electricity basically is the flow of electric energy, and electric energy is the flow of electrons. So let's look at heat energy. Heat energy is heat energy. All matter is made up of tiny particles that are always moving. Since they move, they have kinetic energy called thermal energy or heat energy. Heat is a transfer of thermal energy between objects with different temperatures. Thermal energy travels from a warmer object to a cooler object. So we have words like temperature when it comes to heat energy. There's a measurement of an average kinetic energy of a particle in a substance. You can measure temperature with a thermometer. Let's look at common terms when it comes to heat transfer. We have conduction. Conduction is the transfer of heat energy from one object directly into another. So example, heat moving from iron moves directly into clothing. So that is conduction. Conduction is a transfer of heat from one object directly into another. So example, a cooking pot on fire, that is conduction. Let's look at convection. Convection is the transfer of heat energy through the movement of a gas or liquid. So a gas or liquid is heated and the heat causes it to move upward, like boiling. Boiling is a form of convection. So convection has to do with liquid medium, either, or it has to do with a medium, either through gas or liquid. So like baking, when you're baking a cake, sorry, no, baking is radiation rather, like boiling of water or steaming, it has to do with convection. Radiation, let's look at radiation. Radiation is a transfer of energy by waves that moves through matter in space. Not all radiation from the sun reaches the earth's surface. So baking a cake is an example of radiation. It has to do with the transfer of heat energy by two waves. So it is through radiation that we are able to microwave our food. Radiation is another form of heat transfer, and a typical example is microwave. So this is conduction. Conduction has to do with directly from the heat source, and this is convection, has to do with medium, that is water, example water. And radiation has to do directly with the waves. So these are the this is radiation, these are the heat waves, and that is convection. So when you hear about conduction, you should know about insulators and conductors. Insulators is anything that slows the movement of heat. So it's something that prevents heat from flowing through. Example, rubber. That is why when you realize that on the handle of a metal pot, it's made of plastic or wooden, so that heat doesn't flow through. And anything that slows the movement of heat energy or thermal energy or prevents heat from moving through it is called an insulator. And anything that allows heat to pass through is called a conductor. So anything that allows thermal energy to move through it is called a conductor. So examples of conductors are iron or any form of metal. So this form of energy, we'll leave it for another day, and then we'll talk about it into detail. That is electrical energy. I hope this video helps you answer the question. If you do not understand anything, try as much as possible to watch the video 2 or 3 times to understand what is being said. So until our next lesson, have a nice day. Bye bye.